here we go. I'm going to call this I of t. Starting, putting t here next to the x. So we get the integral going from 0 to infinity. Tx over x to the third power, like so, and then dx. Here we go. Take the derivative with respect to t. So we will first get I prime of t. And for this right here, I will just do the derivative for you guys. We go from 0 to infinity. Differentiate this, we get 3, and then bring the power to the front, so 3, and then sine square, and then tx, and then multiply by the derivative of sine tx, which will give us cosine tx, and then multiply by the derivative of the inside tx in the t world, so we have to multiply by x. That's the chain rule for that part. And then over x to the third power dx. And nicely enough, this and that cancel. What? X squared. Almost. Yeah. Okay. Sine of x squared. I don't really know what to do next. But you see, the deal is that if we differentiate this with respect to t, we can squeeze out an x, and then this x can cancel with an x on the bottom. So if we can somehow do this again, wouldn't it be really nice? Yes, it will. But you really don't want to differentiate this right now because it's a product of crazy stuff, right? So maybe let's do some identity business before we differentiate this again. So, okay, I will use this, let's see. I'll use the identity 3. I'll put this as 1 minus. Alright, let's deal with cosine right now. Cosine square of tx, yeah, and then cosine of tx. Good, and then over wrong column. Over x squared dx. The 3 all the way at the front, no problem. 0 to infinity. Cosine tx. That's good. And then minus cosine to the third power tx. Ooh, shall we really be differentiating this now? If I differentiate this, we get 3 cosine square of tx, and then times negative sine of tx, and times x, and x squared. And then that can cancel with one of the x on the bottom. That's good. And then the problem here is that here, you see, we will maybe right here was 1 minus sine square, and we'll end up with like 1 minus sine to the third power. That's, I don't think it's a good trade-off. So let's try to do what we did before. That is the power reduction formula, not for integral, but just the regular sine cosine business. So focus on that and reduce the power and see and hope for the best. Yeah. So how do we go about this? Let's say we have just that part, cosine of tx times cosine square of tx. Okay, this right here is, oh, there are two ways to go about it, I remember. One is you can write the cosine triple angle formula, and then it has the third power part, and you isolate that. Do I want to do that? Or do I want to do this? I will do this, don't worry. All right, so this right here is equal to this times. I'll give you guys some more flavor for the formula approaches and all that. Anyway, this right here is cosine of tx. What should we do with that? 1 minus sine squared? No, that does not really help. Let's use the polar reduction formula for this, namely 1/2 times 1 plus cosine of 2 input is tx. Parentheses, parentheses, yes. And then we can see this times that is 1/2 cosine of tx. So that's good, that's very good. And then 1/2, and we have cosine times that, right? So it's cosine of tx times cosine of 2tx. And now the product of these two things is equal to 1/2 cosine of first minus second. So tx minus 2tx is negative tx times, no, plus, yeah, plus, the second part is cosine of this thing plus that thing, which is 3tx. Yeah. So let me combine this right here first. So we have that 1/2 right here. So this is 1/4. So this is 1/4. Yeah. So 1/4, and then plus that is 3/4, and then we have cosine of tx, because this right here is the same as cosine of negative t thanks to cosine being an even function. And then this thing right here is 1/4 times that, so it's plus 1/4 cosine of 3tx. So I'm going to do this right here. This is 3 integral 0 to infinity cosine of tx minus all that stuff, which is 3/4, and then we have cosine of tx plus 1/4 cosine of 3tx. And then all over x squared. And keep in mind, we're just using trig identities for all this. Alright, now this and that can be combined. 1 minus 3/4, so this is 1/4, and then we have cosine of tx, yeah? And then it's a minus, be really careful with that. But the point is, the 1/4 can be factored all the way to the front. So we have 3/4 and an integral, and then we have 0 to infinity. And then let me just have cosine tx minus 1/4 is in the front already. Cosine of 3tx over x dx. All right. Now, based on this, let's just do this in our head. I double prime of t. Differentiate this, differentiate that. We still have the 3/4 at the front. We still have the integral going from 0 to infinity. Take the derivative of this, we get negative sine of tx, and then multiply by x, yeah? And then take the derivative of that is, originally it was minus, but the derivative of cosine is negative, so it's plus, and then we have differentiate negative cosine, we get positive sine, 3tx, yes, and then the derivative of the inside, with respect to t, we have to multiply by 3x. Yeah. And now let's split this. So first we have negative 3/4 integral going from 0 to infinity, and then we have sine of tx over just x, because this and that cancelled. And we can close this nicely. Next, 3/4 times 3 is 9/4, so plus 9/4, and then we integrate from 0 to infinity, and then we have sine of tx over x and dx. Yes. All right. For this part, you let t, do a u sub, let u equal to tx, and then right here, we should just say somewhere, let's say t is greater than or equal to 0. Okay. It should be okay, right? There's no violation. Then we can just focus on that. If t is less than 0, thanks to sign being an R function, just put a negative in the front. Anyway, that's what we have. And yeah, you can work this out. You will see it's going to give you, in fact, you can have any constant multiple. This is just going to give you pi over 2. Negative 3 over 4 times this thing is pi over 2. Likewise, plus 9 over 4. And that will give you pi over 2 as well. All this is 3 pi over 4. This is not the answer yet. Alright, check this out. I double prime of t is this crazy integral, yeah? And then we see that it's always going to be 3 pi over 4. Now we have to go back to I of t. So I prime of t, right? We have to integrate this right here first, which is going to be the integral of what? Of this result, which is our 3 pi over 4. In the t world. Yeah, like that. And of course, this right here will give us 3 pi over 4 t, but don't forget the plus c. Now, how do we figure out the c? We have to look back to I of t being this guy. So what do? Again, pick an easy number for t. So let t equal 0. Then we can see that, I'm not going to show you the road right now, just kind of follow along. Put a 0 in here and here. Sine of 0 is 0 thanks to that. So integrating 0 from 0 to infinity is 0. Equal, put a 0 here is 0 plus c. So c is equal to 0. Yay. Now we have this guy. I want to get to I of t, which is the integral of this guy, which is 3 pi over 4 t in the t world. And when we integrate that, we get, that's finished here. We get 3 pi over 8 t squared. Yes, yes. Add 1 and then yeah, and then plus c. Let's say this is c1, and let's say this is c2. Okay, so how do we figure out what c2 is? Again, let's look at I of t, which is this right here, and we have this thing, and I'm just going to let t equal to 0. This thing in blue is 0. Equal this thing when t is equal to 0 is 0 plus c2. So c2 equal to 0. Ladies and gentlemen, I of t, which is this guy, integral going from 0 to infinity of sine to the third power tx over x to the third power dx is equal to 3 pi over 8 t squared. Yes, I'm not kidding. And when t is equal to 1, that's exactly what we wanted. So now let t equal to 1. We get the integral going from 0 to infinity, sine to the third power of just x over x to the third power dx is equal to this thing's 1, right? So we have just 3 pi over 8. Whew.